So, if the limiting value of the function f of x when x approaches a is equals to the limiting value of g of x when x approaches a, both equals to 0, and also f of x divided by g of f exists, then the limiting value of 1 plus f of x raised to the power of 1 over g of x when x approaches a is given by e raised to the power of limit x tending to a f of x divided by g of x. So let us begin by assuming that let a be equals to limit x approaching a. We have 1 plus f of x whole raised to the power of 1 over g of x. Now we take the natural log on both sides. So we have natural log of a equals to limit x approaching a. So we have natural log of 1 plus f of x whole raised to the power of 1 over g of x. Here we can use the property that log of a raised to the power of b is simply equals to b times the log of a. So that is going to give us natural log of a is equals to limit x approaches a. So we have 1 over g of x multiplied to natural log of 1 plus f of x. Now we are going to divide the log by f of x and we are going to multiply it with f of x. Now rearranging the limits, so we will have natural log of a is equals to limit x approaching a f of x over g of x multiplied to limit of x going to a log of 1 plus f of x divided by f of x. So this second limit is going to be equals to 1. So we have natural log of a equals to limit x approaching a f of x divided by g of x. So as per the definition of the logarithmic limit, so the entire value will be equals to 1. Now to find the value of a, so we have a is equals to e raised to the power of limit x approaching a, this is a here, so we have f of x divided by g of x. So let's substitute the value for a. So we have limit x approaching a 1 plus f of x whole raised to the power g of x is going to be equals to 1 over g of x is going to be equals to e raised to the power of limit x approaching a f of x divided by g of x. So this is a standard definition that we will use in solving few problems. For example, let f of x be equals to x and g of x be equals to 1 over x. So we'll have limit so g of x is also x. Both fx and gx are the same function. Then limit x approaching 0 1 plus fx, which is x, whole raised to the power 1 over g of x, which is x. Then this value will be equals to e raised to the power of limit x approaching 0. So we have f of x, which is x, divided by g of x, which is x. So we have e raised to the power limit x approaching 0 1, and the limit of 1 is simply 1. So this gives us 1. So we have a standard result here. Limit x approaching 0 1 plus x whole raised to the power 1 over x is going to be equals to e. Let us do one problem. So here we have the function 1 plus 2 over x whole raised to the power of x, and we have to find its limiting value when x approaches infinity. So when we substitute for the value of x, so we have 1 plus 2 over infinity raised to the power of infinity, and that gives us a 1 raised to the power of infinity indeterminate form. So we can use the definition. So we have limit x approaching infinity 1 plus lambda over x whole raised to the power of x is simply equals to e raised to the power of limit x approaching infinity. So we have lambda over x multiplied to x, so that is going to give us e raised to the power of limit x tending to infinity lambda, which is equals to e raised to the power of lambda. So we have, so for the given function, so we have limit x tending to infinity 1 plus 2 over x whole raised to the power of x, that will be equals to e raised to the power of limit x approaching infinity 2 over x multiplied to x, which will be e raised to the power of 2. So e squared is going to be the limiting value of the given function when x approaches infinity. Let's move on to the next question. So here we have 1 plus sine of x whole raised to the power 2 cot of x. So when we substitute the value of x, so we have 1 plus sine 0 whole raised to the power of 2 cot 0. So sine 0 is 0, so we have 1 raised to the power of, so cot of 0 is infinity. So we're getting an indeterminate form of 1 raised to the power of infinity. So when we use the definition, we are going to get e raised to the power of limit x approaching 0 sine of x multiplied to 2 cot of x, which will be equals to e raised to the power limit x approaching 0 sine of x multiplied to 2 times, so cot x is the ratio of the sine of x divided by sine of x. So the sine and sine gets cancelled, so we have e raised to the power of limit x approaching 0 2 times cosine of x. Now we substitute the value of x, so we have 2 times cosine of 0, so cosine of 0 is 1, so we'll have e squared, and that is going to be the limiting value of the given function when x approaches 0. Let's do another one. So here we have log of 3x base 3 whole raised to the power of log of 3 with the base of x. Now log of 3x can be expanded as limit x approaching 1, so we have log of 3 base 3 plus log of x base 3 whole raised to the power of log of 3 of base x. So here we have applied log of ab is equals to log of a plus log of b, which will be equals to limit x approaching 1. So log of 3 base 3, it's simply 1. That's because log of 3 with base 3 is simply equals to natural log of 3 divided by natural log of 3, which is equals to 1, plus log of x to the base 3 whole divided by log of 3 with base x. Now this can be transformed into e raised to the power of limit. That is because when we substitute for the value of x into this function, so we'll get 1 raised to the power of infinity. So we have e raised to the power of limit x approaching 1. We have fx, which is log of x base 3 multiplied to log of 3 with base x. Now log of 3, log of x multiplied to 3, log of x base 3 is actually is the reciprocal of log of 3 base x. So that means we have e raised to the power of limit x approaching 1. So since the two functions are reciprocal of each other, so that will give us 1. And we have e raised to the power of 1. So the limiting value of the given function when x approaches 1 is going to be equals to e. So let's go to the next problem. So here we have the function cosine of x raised to the power of cot of x. So we need to find its limiting value when x approaches 0. Clearly, when we substitute for the value of x, so we have cosine of 0 raised to the power of cot 0. The cosine of 0 is 1 and cotangent of 0 is infinity. So we're getting an indeterminate form of 1 raised to the power of infinity. So what we will do, we are going to change the function such that we have 1 minus of 1 minus cosine of x whole raised to the power of cot of x, such that 1 minus cos of x becomes f of x. But we know that 1 minus cos of x is equals to 2 times sine squared x over 2. So we can rewrite it as one limit x approaching 0. So we have 1 minus 2 times sine squared x over 2 whole raised to the power of cot of x. Now we can change it to e raised to the power of limit x approaching 0. So we have f of x, which is negative 2 sine squared x over 2 multiplied to g of x, which is cot of x. Now we have negative 2 sine squared x over 2 multiplied to cot of x. So cot of x is the ratio of cos over sine. And also we know that sine of x is equals to 2 times sine x over 2 times cosine of x over 2. So this is the half angle formula. So we have negative 2 sine squared x over 2 times cosine of x whole divided by 2 times, so sine of x will become 2 times sine of x over 2 times cosine of x over 2. So the 2 and 2 gets cancelled, one of the sine x over 2 gets cancelled, so that leaves us with sine x over 2 times cosine of x divided by cosine of x over 2. Now sine of x over 2 divided by cosine of x over 2, so that's a tangent function. So we have e raised to the power of limit x approaching 0. So we have negative tangent of x over 2 times cosine of x. Now let us substitute the value of x. That means let's evaluate the limit. So we have negative tangent of 0 times cosine of 0. So tangent of 0 is 0, so 0 multiplied to negative cosine of 0 will be 0. So we have e raised to the power of 0. So that gives us 1. So this is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So here we have 1 plus x over n raised to the power of n. So when we do a direct substitution, we'll get 1 plus x over infinity is going to be 0. So we have 1 raised to the power of infinity, which is an indeterminate form. So our limit will now get changed to e raised to the power limit n approaching infinity. So we have f of x, which is x raised to the power of n, multiplied to g of x, which is n. So we get e raised to the power of limit n approaching infinity. So we have x. Now the limiting value of x when n tends to infinity is going to be x. So we have e raised to the power of x. So this is going to be the limiting value of the given function when n approaches infinity.